Based lossless compression is a type of compression that we would use on a text file. The reason being is that we don't want to lose any text when we compress a block of text. The reason being is that if words were to get lost, we wouldn't be able to work out what the sentence was saying before. So whereas things like in images we can use a lossy compression, or even in sound files we can use a lossy compression and still be able to interpret the piece of music or the image in question, in a text-based document we would not want to lose any of the contents of the file. So dictionary-based compression is a concept which requires us to take the text and perform or create a dictionary of the words used in the text, and then simply repeat them when they are being when they sort of appear in our dictionary. So if we build an example up here. Let's take this famous quote, I believe from John F. Kennedy. Ask not what your country can do for you, ask what you can do for your country. Now we can see that in a sentence like this we actually have a series of repeated words that we can use to reference again and again. So what we would do in a dictionary-based compression example, we would create a new list. And in that list, we would populate it with all of the words that are uniquely represented within the actual sentence itself. So the word "ask" is the first word that we encounter, and therefore is a unique word. Not what your country can do for you. And then we hit a point where we have a repeat. So we have ask is repeated twice now, so we don't put this in again. What is repeated already. You, we already have that. Can, we have that. Do, we've got that. For, got that again. Your, got that. And then country. So because this is now a list, and if we were programming this, we would index from 0, and if we just put those indexes in just for the purpose of this, let's just add a, oh, hang on a second, I'm a bit crazy there. Let's add a new column in, column to the right, column to the left rather. And if we position these, start with an index of 0, we have 9 unique values in our list. So when we want to actually output this sentence, well, what we can do now is, instead of actually outputting the words themselves, we can save some space in the computer, because we can simply output the actual numbers themselves. So this sentence would look something like 0, 1, 2, 3, and so on. So ask not what your country can do for you, and then ask what you can do for your country. So it looks like that. Now, this particular method I've shown you is a bit of a rudimentary example, because some of you will have spotted straight away, well, there's a comma here, so what on earth would I do with that? Well, in our dictionary, what we'd probably do for this instance is we'd actually have 2 versions of the word you. We'd have you with a comma after it, and then you without a comma after it. That would be one way of dealing with that situation. But what you can see here is that by providing this dictionary and providing the indexes for the letters, we have reduced the amount of text which is here. Is it going to be noticeable on a file size if we were to save it? Probably not, no. But if we were to accumulate thousands and thousands and thousands of words, eventually we would end up saving ourselves a reasonable amount of space without actually degrading or losing any of the text within the file itself. So dictionary-based compression has its uses, not necessarily good for all situations, but would work quite well on a longer passage of text.